like that. So if you look at today, we are going to work with the memory management principle. So the interesting point is memory is one of the resource. So this is one of the important resource, I can say. This is important resource, and this important resource has to be managed very effectively, right? Hmm? Why it is very effectively? Why? Because there are two particular users that are using this memory. One is the system processes, right? Or we can say the daemons, and other is user processes. Okay, so you can have that two processes are being utilizing the resource that is called as memory. So one is the system processes, we called it as a daemons, and user processes. So this can be like this can be either an application, you can take user application, or you can take user task, or you can take a user small process. Okay, so this is the case, right? And this is being used for all for program to execute. And when a program trying to execute its instruction, it has to be into the primary memory. Okay, so all those instructions are to be placed into the primary memory. Right. It's not only the data, not only the instruction, but data also comes into the part of memory. So this, if you look at the memory, it contains, it has to, means with the memory you need to place instruction also and data also. Okay, so instruction and data, these two things are also kept into memory. Now, if you look at the objective here, the important objective is if you really wanted to work with a memory management mechanism, your principal objective should be maximum utilization. Maximum utilization. So we have to utilize memory to the maximum level. Okay, and at the same time, minimum overheads. Means what? Minimum overheads or with minimum complexity. With minimum complexity, your maximum utilization must be there. So when we are trying to do this, we have to look at this, that how the management is going to do, that we are going to keep track of each of the parts of memory that are currently being used, at the same time for which processes it is being used. Okay, so means what? You need to keep this strategy here. Strategy here is you need to keep track and status of uh, each section of memory. Okay, means to whom it is being allocated, when it is to be allocated, right? Means to whom, when, and uh, up to what time. Right, this is important. Okay, so to whom it has to be allocated, when it is to be allocated, and up to what time it is being there. At the same time, what size of the memory is being allocated, right? So this is there. So keep the track and the status of each section of memory. Then you need to decide a policy. Decide policy for such allocations, like when you are going to do, right? When and how. right? So this is important. Okay, so like how you are going to allocate the memory and when you are going to allocate the memory. This condition you need to check. Okay, so you need to design a policy. Then you need to go for allocation method, allocation of the resource, and once it is being used, when once the memory is being consumed, you need to go for deallocation also. What you need to do, you need to go for deallocation, or we can make memory free. Okay, so we need to free up the resources. So this is the case. Now, in order to understand this particular mechanism, what we are going to do, we are going to understand this whole mechanism, memory management mechanism, into this particular way. What we will try to understand the whole mechanism in this way, where we first will see the concept, what exactly concept is. Then second, is there any hardware requirement? Okay. Then we will see that uh, how the software is going to be. Like, because at the end of the day, it is you who is going to write a process for allocation of that particular resource. So how the software is going to look like. Okay, look like, or how it is going to function, and we will end up with the uh, advantages and disadvantages of the memory management system. Right. So this is how we are going to work with each of the memory management methods. Okay. So whatever the memory management method that we are going to do has to be understood into this particular four segment. What exactly the concept is, what sort of hardwares are required, what sort of software looks like, and what are the advantages and disadvantages of that particular methods. Okay, so if you look at the memory management technique, uh, if you look at the memory management technique, so this particular memory management technique is broadly classified into some of the classes. Okay, so we can say memory management. Okay, so this is our basically the section. So this is being done into two particular parts. Okay, so this is contiguous memory, contiguous memory management, uh, and simply uh, second is paging or VM, virtual memory management. Right. So these are the two sections: contiguous memory management and paging and virtual memory management. These are the two sections. Okay. So here, what we are going to do into a contiguous memory management, we are going to have, like, say, two sections particularly. One is called as non-multi-programmed, programmed, and second is multi-programmed. Okay. So if you look at non-multi-programmed and multi-programmed, so the concept we have got is multi-program. What exactly multi-program is? Okay, so first we'll try to understand what is multi-program. So this is an environment where user is allowed to execute uh, more than one job. User is allowed to execute more than one job. Okay, at an instance. Okay, at an instance. So this is important. User is allowed to execute more than one job at an instance. Okay, so in case of this, in case of this non-multi-programmed environment, we have only uh, one memory management technique that is called a single contiguous memory management. Memory management. We have only this particular section, single contiguous memory management. In case of multi-programmed environment, we have three different methods here. Okay, so this is called as this is actually two methods, but like okay, this is called as uh, partitioned memory management. This is partition memory management, and we have relocation. We have relocation memory management. Okay, so this is not going to be we have here, right? No, we don't have anything here left. Okay, so we have only two memory management here, and this is again being divided into two part, that is static specification, static static specification, and second is dynamic specification. Okay, so this is static and dynamic specification. So in case of now in case of paged memory management method, in case of paged memory management method, we have actually been have three segments here. So we'll take up, it is something like this, basically two, that is page, right, and here virtual memory. Virtual memory. So okay, in case of uh, page there is only one method we have, paged memory. In case of virtual memory management, we have two methods here, that is particularly demand paging, and segmented memory, segmented memory management. So in short, if you look at here, so we have to work with how many memory managements? I have just provided you a brief classification of these memory managements. So it is, say, this is first memory management, then this is second memory management, this is 2.1, this is 2.2, this is 2.3. Okay, or you can directly say this is third memory management, then this is going to be a fourth memory management, this is going to be a fifth memory management, and this is going to be sixth memory management. Okay, so in overall we have got 6 memory management techniques. Okay, so one is first is a single contiguous memory management, then we can go for partition memory management, where we have two subclasses, static specification, dynamic specification. Then we have to go for relocation memory management. Then under the paging and virtual memory management, we have paged memory management. Then in case of virtual memory management, there is demand paging and segmented memory management. Okay, so these are actually the classification of the memory management techniques that we are going to have. So this is the most important program, most important segment, that this is called as multi-program environment, and this multi-program environment is allowing me to have this categorization of the memory management method. So this is paging and virtual memory management is also taking the help of multi-programmed environment itself. Okay, so what is multi-program? Where the environment where the user is allowed to execute more than one task or job at an instance of time. Okay, so in case of non-multi-program, what exactly the case is? In case of non-multi-program, the type of operating system will be something like this. In case of non-multi-programmed, in case of non-multi-programmed environment, in case of non-multi-programmed environment, there is one is to one means uh, uh, so one is to one means this one stands for user and this one stands for task. So means one user, one task at instance. At instance, one user and one task at an instance of time. So this is really very important. One user, one task. Okay, so they are actually read as single user, single tasking operating system. Single user, single tasking operating system. So we we use a term called SUST, single user, single task. So these are so kind of operating system, right? Where it is a single user and single task. Okay. So just to give an example of this operating system, example is uh, what MS DOS. Okay, DOS is called as disk operating system. MS DOS is a disk operating system, right? And it is being provided by whom? It is being provided by Microsoft. So MS DOS is a disk operating system. This is being provided by Microsoft. Okay. So, so in case of this MS DOS, only it will allow only one task at an instance of time. So user can do only one particular task at an instance of time. Okay, so which means that everywhere the ratio is 1:1:1. Means what? One user, one task. With one task, one memory. With one memory, there is one processor. Right. So this is user. This is task, this is processor, this is memory. So for example, okay, which means that memory, only one task is active. For a processor, only one task is being executed, right? Only one task is being supplied and only one user is being using it. So this is what. So the basic problem issue with this particular kind of operating system is this poor utilization. Poor utilization. Poor utilization of what? All available resources. Right. And what are the resources available into the system? All. Like again, take. You have a memory, you have processor, you have device, you have files. So at an instance of one file, one device, one processor, one memory. That's it. Right. If there is an opportunity to have execute one more task, but still the system is not able to do that. So this is particularly issue with the non-multi program.